All right, number 3 on the study guide. New slide. Design a wheelchair ramp. All right, so we're dealing with ramps here, inclined planes. That provides a mechanical advantage of 12. So the ideal mechanical advantage of 12 to replace a set of stairs that is 2 feet in height. All right, so this distance is 2 feet. How many feet of non-slipped carpeting will be required to cover the portion of the ramp in contact with the wheelchair? So I also need to know that length as well, the length of that wheelchair, that ramp. Okay, so mechanical advantage of 12. So for an inclined plane, the mechanical advantage is all mechanical advantage, I should say, is always effort distance over resistance distance. So dE over dr, effort over resistance. So I'm looking at distances. My effort force is whatever I'm pushing up the ramp, so along the plane of the ramp. So if that's my effort force, my effort distance is that length along the ramp, not the base, but what you're pushing along. So dE is L. That has to be that length. My dr is the resistance that you're resisting against. Now, the resistance force is going to be, gravity, the weight of the object that's pulling downward. Again, the resistance distance then would be this 2 feet. That's the height that you have to lift up. So an inclined plane with no advantage at all would be, straight up. It would not be an inclined plane at all. Anyways, so I need to lift it 2 feet. That's my dr. And I need an IMA of at least 12. So mechanical advantage of 12. So I need to solve for that length here. I need to solve for dE. So I'm going to multiply both sides by 2 feet, since that's in the denominator. 2 feet, 2 feet. I would get 24 feet. L is 24 feet. So that is the design of my inclined plane. I have 2 feet here. This is 24 feet here. That distance. So how many feet of non-stick carpeting, or non-slip carpeting, although I think all carpeting is non-slip, I would need 24 feet. That's that distance. If you were so inclined and you needed the other distance, this solves the problem. You're done now. But if you went further to say, hey, what is this distance going to be right there, to know what that would be like, then you'd use some Pythagoras Theorem to figure that out, or you could use some trick to figure that out. And I would say, hey, a squared plus b squared equals c squared. So my c is 24 feet, so 24 squared. My a or my b, doesn't matter which is which, is 2 squared plus that side that I don't know. So a squared plus 4 equals whatever 124 squared is. 4 times 24 gives me 576. So a squared, if I subtract 4 from both sides, is 572. Square root of 572 is, where's my square root button? About 23.9. So pretty close. Almost nearly the same. Again, that wasn't asked for in this problem, but if you needed it, if you wanted to find that for whatever reason, that is how you would do it. Moving on.